Okay, so let's go ahead and find the length of x, so that way we can find the length of the entire secant. When we have two secants that intersect outside of a circle, they have a special property with it. And I summarize it as this. You take the outside times the whole thing for one secant, set that equal to the outside portion times the whole secant of the other one. So let's take a look at AC. So the outside portion of AC is 4, and the whole thing is 4 and x, so that's 4 plus x. We're going to set that equal to the outside portion of the other secant, which is 6, times the whole thing, 6 plus 7, is 13. Simplify, and go ahead and keep continuing to solve for x. And you should get x is equal to 15.5. And if I plug that back in to find the length of AC, AC is 4 plus x, and x is 15.5. So the length of AC is 19.5. And AE is, we know because we have both parts, and that's 13. If we have a secant and a tangent that intersect, the same idea kind of applies here. You're still going to take the outside portion times the whole thing and set that equal to the outside times the whole thing of the other line. Okay, so let's take a look at this tangent UV. We'll see the outside part is Z, and I'm going to take that times the whole thing, which also ends up just being Z. Now I look at the outside part of XU. The outside part of XU is WU, and that's 9. And the whole thing is 9 plus 15, which is 24. So we're going to continue simplifying. Z times Z is Z squared. 9 times 24 is 216. And they want our answer in simplified radical form. So we'll take the square root. Perfect square factors of 216 is 36 times 6. So I take the square root of 36 times the square root of 6. So Z is equal to 6 times the square root of 6.